All right, class, welcome to the first video lesson of Chapter 4. We'll be starting in Section 1 this time. We won't be skipping Section 1. The first section covers something known as divisibility and factors. You can find it on page 180. Let's just jump right into this mess. So, something about divisibility and factors. We need to go over what divisibility means. You don't really have to write this down. If you want to, for your notes' sake, that's fine. But divisibility, when we're talking about that, what we mean is that you can take a number and divide it by another number, and you get no remainders. So it's one of those ones that work out so you don't have a fraction or a decimal or a remainder or anything. It just works out like divide a number by another number and you get a whole number as an answer, okay? So these are some divisibility rules for things like those. So divisibility rules for 2, 5, and 10. So an integer, meaning a whole number that is both positive or negative, could be either, is divisible by, meaning if I had some integer, you pick any integer you want, I could say divided by 2. You can divide it by 2 if it ends in 0, 2, 4, 6, and 8. Pick any integer you want. If it ends in here, you can divide it by 2, and it will come out to be a whole number. For 5, if it is it's divisible by 5 if it ends in 0 or 5. And it's divisible by 10 if it ends in 0. Okay, so some of you are thinking, like, wait, what does all that mean? If you need to pause it, remember pause it. Let's look at some examples so you guys get an idea of what it means. Is the first number divisible by the second? Explain. We'll take a look here. I have 140 by 5. We're saying, is 140 divisible by 5? Well, yes, it is. If I divide this together, it all will work out. You can do the math to find it out and stuff like that if you really, really want to. Or you could just take my advice for it, because it says it ends in 0. So that means it is divisible by 5, so it works out. So the answer for this is going to be yes. I'm not going to bother explaining right here. I'm just showing that. I'm going to verbally explain how you would explain. You would just say yes because it ends in 0, okay? Here, you would say, is 53 divisible by 10? No, that's going to have some remainder or decimal left over. You can't do that, for at least for what we're doing right here. So for this, it's no. And the explanation for that would be because it doesn't end in 0. For us to divide it by 10 and it work out right, it's got to end in 0, okay? Over here. So you have 56 divisible by 2. Well, what does 2 have to have? It has to end in a 0, a 2, a 4, a 6, or an 8. Does it have one of those? It does. It ends in a 6. So, yes, this is a yes because it ends in a 6. Remember, any even number is divisible by 2. This is divisible by 2. This over here is divisible by 2, but this one's not, okay? That one, it does not work out. Divisibility rules for 3 and 9, okay? They are a little different than the other ones. You don't look at the ending. You have to add together all the digits and find the sum, okay? So an integer is divisible by 3 if the sum of its digits is divisible by 3. We'll take a look at what that means in just a minute. 9. An integer is divisible by 9 if the sum of its digits is divisible by 9. So what does that mean? So for instance, the question is this divisible? What it means by sum, it means you take these digits and you add them together. What is 6 plus 4? Well, that gives me 10, and that's... Is 10 divisible by 9? Nope. So the answer is no. Try adding these numbers together. What's 1 plus 7 plus 4? Well, you get 12. Is 12 divisible by 3? Why, yes. Ching. So the answer for this one is yes. Okay? No. Boxing those in just so we see them clearer. Now we got this number over here. Is this number right here divisible by 9? Let's find out. 2 plus 8 is 10. And then I see 2 5s over here. I would say to add those together, I would get another 10. Plus, if I add all these together, I see what I'm going to get is a 27. Is 27 divisible by 9? Yes. Ching. So yes. What that means is that this number up here, we know this is divisible by 9. But what I'm saying is if you add all these numbers together and it's also divisible by 9, it makes a smaller number. You see, add them all together, you get a smaller number. We know that this is divisible by 9. You should, hopefully. Then you can also say, well, this number up here is also divisible by 9. It's how it works out. You're like, yay! Math secrets, teach us more. Okay, so now we're going to take a look at factors. So factors are, an example would be like, it's two numbers that you multiply together to get another number. Or you could say, it's kind of like the divisibility stuff. It's when you have a whole number and you divide it by another whole number and it equals a whole number, okay? If you've got like a number like 10 divided by 2, you get 5. You see how all those are whole numbers? 2 is a factor of 10 because you can divide 10 by 2 and get a whole number. That's one way of looking at it. We'll look at some more. Examples. You're told to list the factors of 80. Well, here are all the factors of 80. I have 80 right here, and the factors are 1, 2, 4, 8, 10, 20, 40, 80. Now here's the nature of the way factors work. I could say, I have 80, divide it by 1. What do you get? Well, I would get 80. Both of those are whole numbers. If I have 80 and I divide it by 2, I would get 40. Divide it by 4, I get 20. Divide it by 8, I get 10. And you'll get the reverse as you move this way. If you divide 80 by 10, you get 8. Divide it by 20, you get 4. You see what's going on. So these are all the factors of 80, except I did leave one off. I want to see if you can find a factor that has been left off. There is a missing factor. Actually, there's 2 missing factors. Can you find the 2 missing factors for this? If you can, be ready to share it in class, okay? So find the missing factors. All right, next, we have an example. List all positive factors of each integer. So if we have something like 10, we're told to list all the positive factors of this. So one way I like to do it is I like to pair up the multiples together. What I mean by that is I pair up the numbers that when they're multiplied together equal 10. So I like to pair up my 1 with my 10. I like to pair up my 2 with my 5, okay? That just helps me make sure I don't miss any. If you can do the whole 1, 2, 5, 10, that's great. If you want to do it, list it like, 1, 2, 5, 10. Do it in numerical order, that's fine. I list mine in pairs. It just helps me make sure I have everything there. Next, we're given something like 22. What are the factors? Well, of course, you always have 1 in itself. They're always going to be factors of a number. And then here we're going to have also 2 and 11. And I think that's all the factors. So we're done there. So far we've only had 2 each. Next we've got, oh no, 64. 64 is a doozy. Get ready. Buckle in. You've got 1 and 64. And if you want to pause this and see if you can list out all the factors and then click play and see if you get them all. This would be a great one to test your skills on. So pause the video and see if you get all the rest of the factors and see if it matches with mine. If you click on pause, you should get 2 with 32. You should get 4 with 16, you should get, what's the next one? 8 with 8, okay? And you only have to list the 8 once. If you list it more than once, I wouldn't count off, honestly. But if you list it, it's fine. So these are the factors of our magical number there. Yeah, I think that pretty much covers all theirs. Now we'll look at this one. This is a great example. We'll go over what these numbers are called later, but I'll tell you now, it's called a prime number because if you list the factors of 1 and 17, you list the factors of 17, you'll notice that it's just 1 and 17. You can't divide it by anything, any whole number to get another whole number. It's except by 1 and 17. So that's it. Hope you guys enjoy. Please make sure you take good notes and write down any questions you have.